Hello, my name is Anatoly Ivanov. I'll be introducing you to WebIfcFix. It is an open source web application for editing IFC files directly in the browser without ads or subscription fees. Mm. You also work locally. You won't send your files anywhere else. Let me show you how it works. We'll be using the real world use case I had with my colleagues. Um, And the problem was that he was working in the lesser known CAD software. And upon importing my IFC model, I noticed that all he had in the model tree was the generic names of the elements like beam, column, plate, which wasn't really useful compared to assembly positions, which he can refer to drawings, spreadsheets, specifications, this kind of stuff. So we can do just that. Grab the assembly position property and put it into name using WebIfcFix. Let me show you how. So there's a default layout here. I'll quickly remove those components, and basically what we need is this component, copy property. As I said, we will need to grab tag property and put it in the name. Um, and just like this, it will process all the elements from the model, but that's not necessarily what we need. I specifically know that working on IFC element assembly classes will be just fine for us. So grab the filter by class component and I'll just put in assembly, IFC element assembly. So now we're done. We set up, we can remove those. We can just import our demo building, right? It processes pretty quickly and we can save it to our downloads. Here it is. I'll be using the Sworddesk free online IFC viewer for demonstration purposes. Sworddesk team, thank you so much for the free tool. Another browser-based. Your product is really nice for this demonstration. Please don't sue me. Let's open up the original file as well as the updated one. So in the original, in the model tree, this viewer also has model tree. We can see those generic names: beam, plate. It is here somewhere, right? But in the in our model updated one, it actually useful element positions like column numbers, beam numbers, or bracing numbers, right? So that's it. As you saw, that was pretty fast, and I wrote this script originally very quickly using geometry-gym.ifc library, but I had some issues with running this script on my coworker's office computer because of the limited user permissions and general like version compatibility or runtime compatibilities. So that's when I had this idea of putting this code into the browser environment and Blazor WebAssembly project. When I succeeded with that, I set out to make a great tool which not only I can use, but everyone else can. And here we are much later in the development cycle. Now, because it is a web-based tool, we can just share this layout we created with our colleagues using share layout button. See, a link successfully copied to clipboard. Now, why don't we just use another browser to simulate the another user experience when he follows this link. I'll pass the link. We just downloaded the web application, and there's a quick tutorial for the new users. So got it. Also, this browser is configured to test the light theme. We can turn it back to dark mode here, and now we can finally see that it's exact same layout we just shared with our colleague. So why stop here? Let's imagine a scenario when he asked us to remove unnecessary elements, supposedly like bolts that he doesn't use in his workflow, but they really slow down his computer and he can't really remove them inside the application. We can do just that, but we need to think about our script flow instruction set a little bit more, because when we filter out elements, the filtered parts filters list goes to the next component and next one and next one. And how can we remove the bolts when we're working here with element assembly? We need to grab the filter reset element filter, and now we can find once again work with whole model like in the beginning. We can filter out by class once again. I specifically know that bolts are the class for mechanical fasteners, IFC mechanical fasteners, and use the remove from model component. All we need to do is input our original model here. Boom, save it to the downloads, and we can go back to our viewer to demonstrate the lack of bolts. And surely there's no bolts in the updated model. Bolts, a lot of bolts here. And we still have this we still have the part of the script which outputted the assembly numbers to the name property. So I just demonstrated you a basic usage of the WebIfcFix on these specific use cases, right? But I believe that WebIfcFix is actually really flexible, and there's a lot of capabilities for quickly fixing model you're working with. I'll be committed to make this tool really useful for and free for BIM engineers. But I'm alone will never be able to make tooling as great as one for programming. So if you are C# developer, specifically, especially if you used to geometrygym.ifc library, you'll find it extremely easy to add new components like this to the project. On the GitHub repo, it's mid licensed, by the way, there's a short code example of adding new component here to get you started. So I really encourage the open source community contributions, as well as the generic feedback, constructive feedback on the program performance. And if you find some nice use case, you can share it with public on the social media, maybe with the hashtag WebIfcFix. If you watched this video till the end, thank you so much. I hope the WebIfcFix will help you out in your workflow somehow. Have a good day. Bye.